because of all of these, issues, developed countries have gone on to manufacture replacements. All right, and so some of the replacements that are being used right now are these up here: HCFC22 and HCFC14 or 141B, and this particular compound is CHClF2, and this one is C2H3Cl2F. You should be able to write the Lewis structures for those two compounds. And I'll just tell you, this C2, there's two carbons in these Lewis structures. Carbons tend to string together. So it's like that, and then you just place all the other atoms around. So you can put the fluorine, chlorine, chlorine, hydrogen, hydrogen, hydrogen. And exactly where they're placed you wouldn't necessarily know. You just know that the hydrogens are all terminal and the halogens are all terminal. The F may be over here or over there, but you would have to have more information to know that exact structure. And then this one's pretty straightforward. But anyway, the difference here was by having adding the hydrogen, adding the hydrogens, it makes these compounds a little bit less stable. So the CFCs, last in the environment for like 110 years, and this particular replacement is only lasts about 20 years. It's just less stable. It's going to break down sooner because the hydrogen is a weaker bond and it's a less stable compound than just having it completely covered with fluorine and chlorine. This is the most widely used substitute right now in refrigeration units. It's still, and this one is used. This one's most widely used in refrigeration units. This one's most widely used in foaming agents to make plastics that are kind of puffy, basically, like think of styrofoam, for example, and also foam insulation. So these types of these are the most common replacements for CFC 12, 11, and 12. Now, however, there's still chlorine present on these substitutes. So these substitutes actually are supposed to be phased out by the year 2015. Okay, we're already to 2010. So by 2015, these should be phased out, and then in the next generation, so it's like a stepwise change. And then the next generation of CFCs, if you will, it's no longer going to be a CFC. It's just going to be a refrigerant because we've taken the chlorine completely off. But anyway, the next generation are these HFC 125 and HFC 32. This structure or formula is C2H-F5, and this is CH2F2. And you see what's missing here is chlorine. So the refrigerants have evolved to remove the chlorine. And so what's happening is, since this is going to be the next generation, then the next generation of air conditioning units, refrigeration units, will be designed slightly differently because all of these have different boiling points. The engineering has to change slightly to be sensitive to the exact refrigerant that you're using. So this will be what the newer air conditioners and newer technology uses in general, air conditioners and refrigeration units. Okay, so the world has, there was a problem, and people have responded to the problem. There's one more thing I haven't mentioned as far as types of compounds that are ozone depleters, and that is, in general, this class of compounds called halons. Halons, it's from the word halogen, and halogen are the group 7A. Let me just remind you, this particular group on the periodic table, these right here, these elements, are considered halogens: fluorine, chlorine, bromine, and iodine. They have similar, chemical and physical properties. And anyway, so halon is from the word halogen, and they're carbons that have either bromine or fluorine in addition instead of chlorine as the halogen. Okay, so they're bromine or fluorine containing hydrocarbons, basically. And I haven't mentioned them yet, but these particular compounds were very, very good for firefighting, and they're actually worse for the stratospheric ozone. They weren't used as much as chlorofluorocarbons because they're not used in air conditioning units, so they're not, as many tons of it produced, but they are in the environment and used for firefighting. And so they have also been phased out, and newer chemicals have been developed similar to the evolution of the chemicals that have been developed for the refrigerators and air conditioning units. So I just wanted to point that out. They are used mostly in fire extinguishers, but there's a whole new, they've also been banned by all of these treaties because of their potential damage to the environment.